All right, so I titled this video, Are We Really Trying to Get Down to the Truth? And as we keep moving forward with this series and, with asking questions about our reality in general, and that really is the ultimate question. Are we trying to get down to the truth, or are we just trying to hear things and speculate things that sound good to us, that create the most conspiracy and give us that sense of, us against the world and the most intrigue? It doesn't have to be right. It could be blatantly and obviously wrong, but we cling to it anyway because it's fun to speculate about it. It's popular to speculate about it. It doesn't actually conform to reality. So many things telling you this is not true, which means accepting this as your reality means that you're really not going towards the truth because you're not willing to look at things that go against it, things that could potentially tell you that this is not true. And if we really want to get down to the truth, or at least as close to it as we possibly can, we have to be willing to look at all sides of something. We have to be willing to look at all sides, all facets of everything, not just what makes us feel good, not just what sounds good, but every little thing, including the things that tell us that this may not be true. And this is how you start to get down to the truth. This is how you start to expand your mind, by having a willingness to question everything, not just question the general narrative, not just questioning what is given to us or what we perceive to be given to us, but to also question the alternative, question the quote unquote conspiracy. Does it really fit? Does it really work? Is there strong evidence to support it? Are there things that we can see that show that there really is a true reality to it? This is the difference between being a conspiracy theorist and being a truth seeker, somebody who was really trying to get down to the truth. And obviously this current series is called The Truth About Space. And we're at a point where having a basic understanding of our reality is vital, is paramount. We have to have a grasp on what could potentially be real and what can't work. Because if you're keeping up with the series, you see where we are going, and where we're going, trying to get towards that ultimate truth. Flat Earth doesn't fit. The Earth being flat, a plane, a 2D dimension in any form does not fit. We talked about how the Flat Earth map is a very obvious flattened out 2-dimensional projection of the 3-dimensional Earth, and how you can really see this when you take the time to look at the continents on this thing. You got all the continents stretched out and distorted into these abnormal shapes on this thing, especially when you get toward the edges where you have South America and Australia stretched out like crazy. And because they're so stretched out, you got both of them being on completely opposite sides of the world on this map. Literally on this map, Australia and South America are as far away from each other as any two places can be on the Earth. They're literally both at two separate ends of the Earth. So based off of this map, to get from South America to Australia, you would literally have to travel across the world from one end of the Earth to the other end, which would take you days at the least and weeks at the most. But in reality, we know that there are flights that go from South America to Australia in less than 12 hours, sometimes less than 8 hours. Direct flights that fly over the Southern Ocean around Antarctica to get between these two continents. Again, between 12 and 8 hours in less than half a day. We know these flights exist. We know anybody can book these flights, and these flights are happening every single day, multiple times a day. 8 to 12-hour flights between South America and Australia, between multiple different cities on these two continents, with hundreds of thousands of people taking these flights every single day. Again, these flights are made by flying across the Southern Ocean around Antarctica. And when you're on these flights, you can literally look right outside your window and see the Southern Ocean, see all the ice covering the Southern Ocean, see that you are literally flying over nothing but water covered in ice until you start to see those giant ice sheets that we know should be there in the Southern Ocean. And eventually all of those ice sheets turn into land that is clearly covered in ice. Mountains, plateaus, peninsulas covered in ice. You got what is clearly miles and miles of land covered in ice, surrounded by the Southern Ocean. And depending on which part of Australia and South America that you're going to, you can actually get really, really close to this land. And there is no doubt that you are looking at a continent covered in ice. They actually have these special scenic flights that you can book that get you extremely close to the continent. That puts you like right on the edge of the continent. And again, you can just see how much deeper the interior goes in, that it is definitely surrounded by the Southern Ocean, and that the further and further you go in, the more mountainous it gets, the more land that you see. A continental landmass covered in ice. No ice wall, no dome, just miles and miles of land. Uninhabited land. Now again, you're flying over the edge of the continent. You're flying past the continent. So you're not flying over the South Pole or the deeper regions of the continent. Just the very tip. But even with just that little bit, there is little to no doubt that you are flying past a continent, that you are flying past Antarctica, and that you are looking into the outskirts of a much larger, deeper continent. One that, again, is right between South America and Australia, just the way it would be on a spherical Earth. And again, all of this takes less than 8 hours. 8 hours to get between these two continents. While again, flying over the Southern Ocean past Antarctica, which again, based on the flat Earth map, should take days at the least, weeks at the most. And keep in mind, this is a direct flight. So basically a straight line from South America to Australia, which again, based on the flat Earth map, means that you will be flying over North America, the entire Arctic Circle, Canada, Russia, Norway, Greenland, Alaska, the North Pole, over the tip of Asia, and then finally get to Australia. And again, it would still take you days, possibly weeks, to complete that flight. And let's just say every pilot is in on this conspiracy, and they are making a crazy loop around the ice wall without anybody noticing. Number one, there would never be a point when you would not see the ice wall, since it's supposed to be wrapping around the entire Earth. You would never just see ocean like people actually see on these flights. And again, hundreds of thousands of people have taken this flight and continue to take this flight. And not one person has ever mentioned seeing an ice wall or taking footage of an ice wall. So is everyone that takes this flight being initiated into the secret of the ice wall? And even if they were somehow looping around an ice wall without anybody noticing and somehow magically making it seem like a straight route, that route would take you even longer than a straight route, because you'd be traversing a full third of the circumference of the entire Earth. And no matter where your flight ends, no matter what city you land in, you would always have to take this crazy loop, sometimes flying over other cities, multiple cities, including always having to fly over or fly past the entire island of New Zealand to your destination, which we also know never happens. So we already know only one of these is truly matching reality, is truly matching what everybody is experiencing every single day. And again, we already know these continents are stretched out and distorted on this map because it is a 2D stretched out version of the three-dimensional Earth. And Australia is the best example of this because you can see how abnormally stretched out this thing is. It is literally stretched out like a log. I mean, this thing is so stretched out, it is no longer recognizable as a continent. It is so stretched out, there is no true north or south in Australia on this map. And because of this, the distances between different locations make no sense on this map. Because this thing is so stretched out, you have these crazy distances between different cities, and you have cities in locations where they are not actually located. Again, there's no north or south like we know Australia actually has. And this is why you won't find a lot of Australian flat earthers, because they know that this is not what they are living on. This is not the country that they navigate every single day. And again, you got this distortion with pretty much every other continent on this map. They're all stretched out abnormally, but because Australia is so close to where the spherical Earth has been stretched out, you can see that distortion the most there. And obviously, if the Earth is flat or on a plane, level in any type of way, even if it's sitting inside of a crater, which would mean it would be on a level surface or flat surface, because it would be sitting on that flat surface, everybody's perspective of the sky standing on that level surface should all be the same. Everybody should be seeing the same star constellations. Everybody should be seeing the same pole star. Every single person on Earth should be able to look around at the sky above them, and they should all be able to see the same stars. And if the North Pole is the center of the Earth, like many people believe, then every single person on Earth should be seeing Polaris as the pole star. Everybody should be able to see the Little Dipper. Everybody should be able to see the Draco constellation. And every single person should be seeing the stars rotate in the same exact direction. Because you're standing on a flat level surface, no matter where you are standing on the Earth, every single person should see the same stars rotating in the same direction. But we know that people in the northern hemisphere see the stars rotating clockwise, and people in the southern hemisphere see the stars rotating counterclockwise. The stars are moving in two completely opposite directions in the north and the south. When you look at the flat Earth map and you look at South America and North America, of course, they're right next to each other, and they are both on this flat level surface. So again, people in North America and South America should be seeing the same thing. They should all be seeing the stars rotate in the same direction, and they should all see Polaris as the pole star. They should all be able to look up and see the same constellations, see the same perspective of the sky. But in reality, people in South America see the stars rotate clockwise, and people in North America see the stars rotate counterclockwise. Again, two completely different directions in the north and the south, which makes sense when you place these two locations on a spherical Earth. And you can see how this will work if you take a basic globe and you rotate it counterclockwise. From the top of that globe, from a northern perspective, it's going to look like things are rotating counterclockwise. But on the bottom of that globe, in the southern portion of that globe, it's going to look like things are rotating clockwise. Same exact motion, same exact rotation, creating two distinct perspectives in the north and the south of a spherical object. Again, it makes sense why people in North America, closer to the northern axis of rotation, would see the stars rotating counterclockwise, and why people in South America, closer to the southern axis of rotation, would see the stars rotating clockwise, and why every other country in the north and every other country in the south is experiencing the same exact thing, and why everybody is not seeing the same stars. Because again, people in the south can't see the Draco constellation, they can't see the Little Dipper. When people in the south look up, they can see the Southern Cross constellation, which no one in the north can see. When they look for the pole star or the center star, they don't see Polaris. They see Sigma Octantis. Again, a completely different pole star that is, again, surrounded by a completely different set of stars. When people in the south look at the Big Dipper star cluster, from their perspective, it looks like it is upside down compared to people in the north who see it right side up and see it at a different angle in the sky. People living in the southern hemisphere are able to see the Magellanic Cloud Galaxy, a small galaxy that you can only see in the southern hemisphere. No one in the northern hemisphere can look up and see this collection of stars and elements in the sky. And again, all of this makes sense on a spherical Earth with two separate pole stars surrounded by different sets of stars, and people on this spherical Earth experiencing these two different perspectives, northern and southern hemisphere perspectives. We know people in the north see the moon right side up, and people in the south see the moon upside down, which again is showing you that there is a different orientation for these two locations on the Earth. And it only really makes sense if that orientation is north and south on a three-dimensional spherical Earth. And obviously one of the other issues with the Earth being a flat plane is the sun. Because if the Earth is flat and the sun is always rotating above it, then you would think that we should always be able to see the sun, because there will be no curve, no boundary blocking us from seeing the sun. Just like we can look up and see the stars in the sky, you would think we would always be able to see the light of the sun rotating above us, that everybody on Earth should be able to look up and always see the sun. And that if the sun is right above us, shining down onto a flat plane, that the light of the sun should be lighting up the entire Earth. Because we know how light works, it travels in all directions. Unless you have something containing that light, it will spread, especially when you have a light shining down from above. This is how lighting works in a room. That light placed high above the room lights up everything below it. And again, the only way you can stop that light from spreading is to place some type of barrier around it, which we know the sun does not have. So again, it should be spreading in all directions across the entire flat level Earth. But we know only certain places on the Earth are getting sun at different times. And almost everybody on Earth is experiencing a 24-hour day and night cycle. The seasons are exactly opposite in the northern and southern hemispheres. And this makes sense if the Earth is spherical and only getting sun in certain regions. And it doesn't really make sense with the sun and the moon just arbitrarily circling around the Earth. And of course, a lot of people say that the sun is giving off this spotlight effect, so that light isn't spreading out in all directions. It's only lighting up whatever area it rotates over as it moves across the flat Earth. And then the moon is actually its own light source, that the moon is giving off its own light, and that the sun and the moon are basically two separate lights circling around us in the sky. But even if that was true, that would mean we have two separate lights in the sky, 2 times the light in the sky, constantly circling around us. So again, you would think we would always be able to see these lights in the sky, and that there will always be light in the sky. But we know we can zoom into the moon and see that it is not its own light source. It is very clearly a physical object that is reflecting light off of it, which we can only assume is the light of the sun that is lighting up this object in the sky. And depending on how much light hits it, how much light it reflects determines how much of the moon you will see. This is why we have moon phases, because of the light of the sun reflecting off of different parts of the moon. And whatever parts that light doesn't hit, you cannot see, because the moon is not a light. It is an object reflecting light. But let's just say the sun and the moon are their own separate light sources, and they are rotating above us And as they rotate, they are somehow moving out of our line of sight. They're moving so far away from us that they're converging into a vanishing point as they circle around the earth. Again, we know as things move out of our line of sight, they get smaller. Things moving out of our line of sight get progressively smaller and smaller until they finally converge into that vanishing point and completely disappear out of our line of sight. And you can see the process of that object continually getting smaller as it moves out of your line of sight, as it moves away from you. So if the sun and moon are moving away from us as they circle around the earth, we should see them getting smaller until they vanish out of our line of sight. But when we observe the sun and the moon rising above the horizon and setting below the horizon, we can see that they never change size. We can see that as they move down below the horizon, they never change size. You see the full size of the sun, full size of the moon drop completely below the horizon and rise completely above the horizon with no change in size, like they are moving away from us. With the sun, you can get into atmospheric refraction and things going on with the light that can cause it to look differently. But again, even with the moon, we see the full body of that object drop completely below the horizon and rise completely above the horizon. The full body of the moon, no change in size, no atmospheric refraction, no light distortion, just the entire body of the moon disappearing below the horizon and reappearing above the horizon without changing size. And with the moon, you can actually see how as it gets closer to the sun, as it rises and it gets closer to the sun, it begins to reflect more light. Again, just like that light is being reflected from the sun. And with the moon closer to the horizon, you can see that the moon is not a perfectly round object like it seems to be at those higher altitudes. You can see that just like they're telling us with the earth, that the moon is more of an oblate spheroid, flatter at the top, rounder at the equator. And again, wherever the sun is in relation to the moon is where you're going to see the moon lit up. It's where you're going to see the light reflecting off the moon. And again, light or no light, we always see the full body of the moon move completely below the horizon. We always see the full body of the sun rise and set completely above and below the horizon. No change in size, as if they are going above and below a curve, as if they are moving around the curvature of the earth. So you got two conclusions. Either the sun and the moon are moving around the curvature of the earth, or they're somehow magically disappearing into the plane of the earth. And no one anywhere has ever been able to record the sun and the moon magically disappearing into the ground. We know when people use P900 and P1000 cameras and they zoom into the setting sun or zoom into the setting moon, they cannot pull them back in. They continue to drop below the horizon, again, without changing size. And the only way this really makes sense is if they are moving around the curvature of the earth. Some people say they could be moving outside of the dome of the flat earth. But even if that was the case, you would have to throw everything we can observe about the northern and southern hemispheres completely out of the window. The sky rotation, the moon orientation, literally everything we can observe, you would have to throw out of the window. And then you would have to explain, where are the sun and the moon going when they go below the dome? Because we know once sun and the moon drop below the horizon for us, they are rising above the horizon for someone else in another location. And again, this can really only be explained with sun and a moon moving around a spherical earth. Again, we know that the sun and the moon aren't the only thing moving around the earth in the sky. We can see with time-lapse photography that everything in the sky appears to be rotating around the earth. Every single star, every single celestial object appears to be rotating in unison, rotating together in the same direction around the earth. And the only things in the sky not seeming to follow that path of rotation are meteors, shooting stars, which we also constantly see moving through the sky. If you take a time lapse of the sky, you're going to see dozens of shooting stars moving through the sky just within 1 hour of a time lapse. And again, they're moving at a different speed and a different angle than the constant rotation of everything else that we can see, which is letting you know that there are definitely celestial objects moving independently in the sky, in space. But from our perspective, at least about 90% of everything in the sky appears to be rotating around the earth in the same direction, in unison, in a circular motion. And we know that this rotation is constant because when the sun rises, when the sun lights up the sky, we can see that that is the only thing preventing us from seeing it. This constant rotation, constant circular motion of just about everything in the sky. So again, from our perspective on Earth, just about everything appears to be rotating in unison. Now, right here on Earth, one of the things that can replicate a similar perspective is a gyro tower. As it moves up into place, as it rises up into place, begins to spin in place. It begins to spin in place as you sit or you stand in a fixed position on it, looking outward at the landscape around you, looking at everything around you from that spinning perspective, all the scenery around you from a rotating perspective. So again, once that gyro rises to its highest point, with you stationary on it, looking outward, and it begins to slowly spin in place, from your perspective, it's going to look like the landscape around you is rotating. Like all the objects around you are rotating in the same direction, in unison. It's going to look like everything is rotating around you. Everything except things like cars that you know are moving independently at a different speed and at a different path. But from your perspective, sitting stationary on that spinning gyro, it's going to seem like about 90% of everything around you is rotating. Like just about everything is rotating. And when you compare this to the way we see objects in the sky appear to be rotating and moving in and out of our line of sight in the sky, it seems to fit perfectly with that perspective of us viewing things while situated on an object that is in a constant spinning motion. Again, with just about everything seemingly rotating around us. And you can actually start to see this perspective even more if you take the perspective of that gyro and you flip it to a different angle. Turn it sideways, similar to how we see the stars. And again, you can see how everything appears to be moving in unison. And as it rotates, or as we rotate, everything continually drops down away from us, out of our line of sight. Again, as we sit stationary on this spinning object, rotating at that particular angle. From our perspective, this is how it would appear to be, how everything would appear to be moving around us. We know the sky appears to rotate in different directions in different parts of the earth. Again, you can take that rotating gyro perspective, you can flip it around to match those same angles that we see the sky rotate in different parts of the earth. Again, you can see how from our perspective, how it would look like just about everything is rotating around us and slowly moving out of our line of sight. as we look out at the landscape around us on an object that is in a continuous spinning motion. And again, we know depending on where you are on the earth, the sky appears to rotate in different directions. We know closer to the poles, the sky appears to rotate clockwise and counterclockwise in a near perfect circle. At areas between the pole and the equator, the sky appears to rotate almost at an angle, at an up and down angle. It appears to be going up closer to the north and down closer to the south. And for places at the equator, which, would be the middle of a spherical rotating object, the sky appears to rotate in a straight line, right to left or left to right. Left to right closer to the south, right to left closer to the north. So again, depending on where you are on the earth, you have different perspectives of this apparent rotation of the sky. Again, a near perfect circular motion closer to the poles, where you would expect the top and bottom of a spinning spherical object to be, going clockwise and counterclockwise, just like we would expect to see on a rotating object. The sky moving at that slight slant up and down between the poles and the equator, slanting slightly up at the north and slanting slightly down at the south. Again, just like we would expect from the curved angle of a spherical rotating object. A straight line, left to right and right to left at the equator. Right to left closer to the north, left to right closer to the south. Again, just what we would expect at the center or the middle of a rotating object. But again, if you look at this from the perspective of us viewing the sky on a rotating object, these different perspectives of the sky make sense, and why different people, different regions of this rotating object, this slowly rotating object, would see the sky rotating from different perspectives, from different angles that all add up to us being on a spherical rotating earth that is slowly rotating and not whirling around like a hot rod, like a lot of people envision it, because a lot of people are going by that 1,000 miles per hour rotational velocity, not understanding rotational speed in relation to the size of the earth, the massive size of the earth. You got to remember the earth is huge, so that rotational speed is in relation to its size and distance. And you can actually look at it this way. One full rotation of the earth equates to one full day and night cycle. One full day. So one full turn of the earth equates to one day. So the earth makes one full rotation all the way around just one time every day, every 24 hours. One full 360-degree turn every 24 hours. One time every 24 hours. That'd be like you turning in place and trying to make one full turn stretch out to 24 hours. This is how slow the earth is actually turning, but it's got a way more massive circumference, way more range all the way around, way more width all the way around. And as it turns, more and more of that range or more and more of that width is covered by that rotation. And again, the earth is huge. It's supposed to be about 25,000 miles in circumference, 25,000 miles all the way around. And as it rotates, that rotation covers 1,000 miles of the earth's circumference every hour. So it's not actually spinning at the speed of 1,000 miles per hour. The earth is not moving at 1,000 miles per hour. It's about how much of the circumference of the earth is covered every hour by its rotation. And again, as the earth turns, as it rotates, that rotation clears 1,000 miles of the Earth's full 25,000 mile circumference every hour. So again, that 1,000 miles per hour is about how much of the Earth's circumference is being cleared as it rotates, which is why when you look into it, they say that the Earth rotates at 0 miles per hour directly at the North and South poles, because there is no ground to cover, no miles, no circumference to clear directly at the pole, directly at the Earth's axis. So even though it's still spinning at a certain speed, even at the pole, that rotation is not covering any ground at the pole, which is exactly what that 1,000 miles per hour is talking about. It's about how much ground is being covered as it rotates, not the actual speed, how much of the circumference is being covered. Because the Earth would be a spherical object, the Earth's actual rotational speed is measured in RPMs, or revolutions per minute, which is how you measure the speed of a 360-degree object. And with the Earth making a full turn or a full rotation just once every 24 hours, that equates to the Earth turning at just 0.000694 revolutions per minute, which converts to just 16 miles per hour. So in reality, the Earth will be rotating at 16 miles per hour. And again, that 16 mile per hour rotation covers about 1,000 miles of the Earth's overall circumference in an hour. That 16 mile an hour rotation clears 1,000 miles an hour of this massive, 360-degree object. 1,000 miles of this massive object every hour. So again, it's not whirling around like a tornado or a cyclone. That rotation is extremely slow. It'd be like trying to make a 360-degree turn in your car and trying to stretch that 360-degree turn out for over 24 hours. This is how the Earth rotates, but on an even larger and more massive scale. Based off of the Earth's size, it's actually moving at about half the speed of the hour hand on a clock. This is how slow that rotation is actually going. That's why you can't just look out at the sky with the naked eye and watch the stars rotate. You have to set up equipment for hours and hours to create a time lapse of the sky to see that rotation, because that rotation is extremely slow. Again, Earth is massive. It has a massive circumference, but we can look up and we can see these different movements of the sky, right to left, left to right, clockwise, counterclockwise, that slant up and down. And when you put all these perspectives of the sky together, it is clearly outlining a sphere, which is why in astronomy, the sky is referred to as the celestial sphere, because everything moves and appears to be orientated in the form of a sphere. Again, as we look at the sky from these different angles, from these different regions, from these different hemispheres, it is clearly giving us the outline of a spherical object, a 360-degree spherical object that is in a constant state of rotation, constantly turning in the same direction, while we move with it and view that rotation from the perspective of the sky. Again, you put all these different perspectives of rotation that everyone experiences every single day on the Earth, and they come together to give us a spherical rotating object that we are stationary on, viewing that rotation from an outward perspective. Different movements of the sky that really only make sense if the Earth is a spherical object. Sometimes we can look up during the day and we can see the sun in the sky, and at the very same exact time, not too far across the sky, usually at a slightly different angle and a different distance, you can also see the moon in the sky. We can see the sun and the moon in the sky at the same exact time. And when we see them, we can clearly see that the only parts of the moon that we can see are the parts that the light of the sun is reaching, which is an indication that they are at separate angles, separate positions in the sky. And we can usually see this, a few days out of each month. The sun and the moon in the sky at the same time. And while we can look up and see them wherever we are on the earth, at that same exact time, someone on the other end of the earth only sees the moon in the sky, and someone on the other end only sees the sun in the sky. Now you gotta think, if the sun and the moon are at separate distances, rotating above us, literally rotating over our heads at separate distances across the full length of the earth. One's rotating over Australia and one is rotating over South America at completely separate distances across the entire earth. And according to Flat Earth, completely moving out of our line of sight as they rotate around the entire earth. How would we ever see the sun and the moon in the sky together at the same time? We know we don't see the sun and the moon in the sky in the same place every day and night. They change position from day to day. Sometimes we see the moon closer, sometimes we see it further away, which makes no sense if they're just rotating above us across the earth in circles in a set loop. Again, if the sun and the moon are circling around above us, and this is why we can see them both at the same time, we should always be able to see the sun, because it should always be just right there above us in the sky for us to see it. We should never see the sunset. We should never see the moon set. But we know the sun drops below the horizon and we know the moon drops below the horizon. And when the sun drops below the horizon, it takes its light with it. And no matter how much you try to zoom into the sun, you cannot pull the sun back in. Because if you could pull the sun back in, then that means that you could zoom in and literally pull back daylight, literally pull the day back in, literally bring the day back just by zooming in. But we know nobody has ever zoomed in during the night and pulled the sun back in. Once the sun has gone over the horizon, it's gone. Once the moon has gone over the horizon, it's gone. And again, we do not see the sun and the moon in the same position in the sky every single day, which indicates that they are taking different paths, different trajectories. We know we have 4 seasons all over the earth, which can only be possible with multiple cycles of the sun and the moon. The sun and the moon moving above us in a circle is only one cycle, meaning only one season. And you get a lot of people that try to explain this on a flat earth by saying that the sun and the moon are moving further inward, moving in and out above the earth in this circular motion. And they say this is how we get different seasons, and this is how we sometimes see the sun and the moon cross paths, which still does not explain time zones and seasons. Because we know we got places like Norway where people are experiencing 6 months of daylight and 6 months of darkness. You got small areas like the tip of South America, Argentina, that stays in daylight for 17 to 18 hours a day, which again cannot be explained with the sun and the moon going around in circles above us. And even if that was the case, if somehow the sun and the moon were rotating in circles above us, literally right above us, right above the earth, right above our heads, then people in different parts of the earth should be able to look up and see the moon right above their heads. We should be able to look up and see the sun and the moon circling right above our heads, if they are circling above the earth, moving in and out right over the top of each continent. We should be able to look up and see the sun and see the moon move over our heads and vanish off into the distance as they circle above us. But in reality, every single person on the earth sees the sun and sees the moon beyond the horizon at a distance. No one is looking up and seeing the bottom of the sun or the bottom of the moon. No one is seeing the sides of the sun or the sides of the moon moving away from us. Everyone everywhere on earth sees the same face of the moon. No matter where the moon goes, no matter what position it is in, we all see the same face of the moon. The only thing we see different is it appearing right side up in the northern hemisphere and upside down in the southern hemisphere. But whether it's right side up or upside down, we all see the same face of the moon, the same side of the moon, letting you know that it must be at a distance moving around the earth. Even when we see the sun and the moon in the sky at the same time, somebody on the completely opposite side of the earth is seeing the exact same face of the moon, the same side of the moon, which is letting you know that it must be at a distance, moving around the earth. It will be like you walking around in a circle above a group of people. As you walk around in that circle above them, all of those people would see different sides and angles of you. They see you from the bottom, from the sides, some of your front, some of your back. They'd be able to see all these different angles as you circle above them. The only way everyone, everywhere, no matter where they are, would only see the front of you, only see you from a front facing position, walking around them in circles, is if you're walking around them from a long distance, from a far off distance, locking in to that front facing angle as you go around them, which is exactly what we see the moon do, going around us beyond the horizon at that same angle, that same facing position. We have never seen the face of the moon change. As long as the moon has been recorded, we have never seen the face of the moon change, which is letting you know that it is tidally locked, moving around the earth at a distance. Again, we never see the sun moving across our heads. We always see it beyond the horizon, moving above and below the horizon, which is again letting you know that the sun is at a distance away from us, away from the earth. And because they're not just spinning in circles above us, but instead, moving around us at a distance, we get the possibilities for them to, cross paths, which of course creates eclipses, solar eclipses, where we see the moon move in front of the sun. And we know that a solar eclipse is happening beyond the horizon at a distance away from the earth, because when a solar eclipse happens, millions of people can see it miles apart, happening the same exact way, at the same exact time, at the same exact angle. And as long as solar eclipses have been recorded, no one anywhere on the earth has ever witnessed a solar eclipse where we see the sun and the moon from the bottom, where we see them right over our heads, where we see the bottom of the sun and the moon over our heads, where we just look up into the sky and watch the sun and the moon crisscross each other in the sky, watching them from the bottom of the sun and the bottom of the moon move past each other, cross past each other in the sky, and rotate off into the distance. No one has ever seen the sun and the moon move past each other from the side, from a side angle, and again, rotate off into the distance. Every eclipse happens from a front facing angle, far off in the distance, beyond the horizon. And it makes sense if we can see the sun and the moon in the sky at the same time, at different times throughout the month, that we are eventually going to see them cross paths, that we are eventually going to see them eclipse each other. And just like we're able to see the sun and the moon sharing the same sky about 11 days out of each month, we also know we get at least 2 to 5 solar eclipses every single year. And every 18 months or so, we get a total eclipse where the moon completely covers the sun. But even before that total eclipse, we got 2 to 5 times out of the year where the moon is crossing paths with the sun, and we are able to see it. We get those partial eclipses where the moon moves across the sun at different angles, and it doesn't totally eclipse it. Sometimes it moves across from the side. Sometimes it goes straight down, coming from the top and going straight down across the sun. And then, sometimes it partially clips it from the side and then straight down, which again is an indication that the moon is taking different paths in the sky, is making different transits in the sky in relation to the sun. And again, millions of people seeing the sun and the moon eclipse each other from just one angle, from a front facing angle off in the distance beyond the horizon, really only makes sense if they're out there beyond the earth. And because we know the moon must be at a distance, because we only see one side of it at a distance, basically facing the planet, moving in front of the planet at a distance, we know that during a lunar eclipse, when we see that shadow move across it, that shadow has to be the shadow of the planet that the moon is in front of, that the moon is facing. Of course, that shadow is very clearly spherical. It is very clearly the shadow of a spherical object. And as we see that shadow move across the moon, we also see a faint light of what could only be the sun illuminating the moon from a distance, which really only makes sense if the Earth is positioned right between the moon and the sun, with the moon in front of it and the sun behind it, which really only makes sense if the Earth is a free-standing object that can sit between the moon and the sun. A spherical, free-standing object casting a spherical shadow and partially blocking the light of the sun from the moon. Again, with the moon out there in front of us at a distance, it makes sense that we are seeing the shadow of what we are living on at a distance. As the sun illuminates that shadow off in the distance, that shadow moves left to right in the northern hemisphere and right to left in the southern hemisphere. Again, the exact same way we see the sky rotate, in the exact same way we would expect to see it reflected back on a spherical object. And one of the other things a lot of people say is, the Earth very well could be spherical, but how is water curving on this spherical object floating in space? How is all the water of the oceans curving on this spherical object? Because as far as we see it, water is always level, water always lies flat. So how is it curving around and sticking to a spinning ball? They say we never see water curve, we never see water bend. Of course, waterfalls and waves, ocean waves. But how is the water on Earth curving around the planet, curving around this spherical object and sticking to it while it's in a constant motion, a constant rotation? Well, we know that water in its simplest physical form, in its most minute physical form, curves. It bends around and curves into a droplet. Water in its most basic form naturally curves and conforms into a spherical droplet. So just in one of its most basic natural physical forms, we have water curving. Because remember, water is H2O, hydrogen and oxygen bound together. And when that hydrogen and oxygen binds together to create a water molecule, it is bound together and molded into a sphere. It bends and curves into a spherical water droplet. And this is why you can pour water on a paper plate or paper towel, anything hydrophobic or anything, water repellent, and the water will immediately bound together into a sphere, a spherical water droplet. It will immediately bend and curve and conform into that spherical shape. And it isn't until each and every one of those spherical water droplets combine together that you start to get a larger drop of water. And eventually those multiple spherical droplets combine together to give you a large body of water. So all the bodies of water that we see are multiple spherical water droplets that have been bound and combined together to create a large body of water. So to even get a large body of water, you need curved spherical water droplets first. And because of its spherical shape, water in its most basic form is a polar molecule, or what's called a polar covalent, meaning water is polar. It has polarity to it, polar opposite sides, negative and positive sides, negative and positive properties. And because of that, water molecules are attracted to a negatively or positively charged object, to a polarized object. And that attraction to that polarized object will cause water to curve. It will cause water to bend and curve toward that polarized object. As long as you create a polarized charge around that object, by creating friction around it. Water will attract to it, and it will bend and curve as it attempts to conform to it. Literally, any and every polarized object will attract water to it. And wherever that object is where water is going to conform, is where water is going to curve and bend to try and attach itself to that object through that negative and positive polarized force, through that electrostatic force. Literally any object that can hold a static charge, that can hold an electrical charge, that can be polarized, will attract water to it. And as a result, will cause water to curve and to bend. Literally, you can bend and curve water in your bathroom sink with a hair comb. As long as you charge that comb with friction, as long as you polarize it, you can literally bend and curve water with a hair comb. Because again, water is a polar molecule that is attracted to polarized objects with a static or electrical charge. And the more charge an object has, the more potential it has to attract water. And of course, the larger the object, the more capacity it has to hold a greater charge, to create a greater polarization and a greater attraction. The larger the object, the greater the ability to conform water to it, to attract water to it through that polarized force, causing water to curve and to bend. And remember, the earth is polarized. It has magnetic poles. The earth is a massive polarized object, and that polarity flows all throughout it. So it'd be tough not to think that there are similar forces acting on the planet on a larger scale, causing it to conform to the planet and take on the shape of the planet on a scale that we cannot visually comprehend, being smaller than ants in comparison to the planet. But then obviously the next question is, how is that water sticking to a spinning planet, to a rotating planet? How is the planet rotating around and keeping all the water with it, keeping all the water attracted to it as it moves in a constant rotation? And this is where we got to look at centripetal force, or uniform circular motion, rotating an object in a 360-degree motion, creating a force that keeps everything contained within it.